In this section of notes, we're going to look at the idea of a significance test for means. I think I mentioned before in class that things start to get pretty repetitive. So we spent a lot of time in the previous unit looking at proportions. We did confidence intervals and then tests, and then we did 1 sample and 2 sample, and we're kind of on the way to doing all of that again with means. So we've already done a confidence interval for means. Now we're going to look at a significance test. So we've got this scenario here where we've got our AAA batteries, and the claim is that they say that their AAA batteries last for 30 hours, and we've got a simple random sample of 15 that had an average lifetime of 33.9 hours, the standard deviation of 9.8 hours, and we want to know, does this provide convincing evidence? Is it surprising? Is it statistically significant? Is it unusual? Remember, all of those things mean the same thing, and they're all hints that you should conduct a significance test. So, just like we did in the previous unit, our first step, we've got the state plan do conclude outline, and our first step is to set up our hypotheses. So we'll start with saying, well, the claim distribution has a mean of 30 hours, and we have some evidence to suggest that maybe it's more than 30 hours. After the state step, we moved on to the plan step, and that involved checking the conditions. The good news is that these are the same conditions we used 2 units ago when we were doing sampling distributions. These are the same conditions we used in the last section where we did confidence intervals for means. So you want to check that either the sample is randomly selected, or if it's an experiment that you're doing random assignment. If it's a sample, you want to make sure that the sample is less than 10% of the population. And you want to check your normal condition or your large counts condition. And remember, there's 3 things that could happen. You just need one of the 3. You don't need to check all 3. So you either need to know that the population was normally distributed, or you can use your central limit theorem and your sample size can be 30 or more, or you can make a dot plot of your sample and show that there's no strong skew or outliers. So same conditions that we're getting used to here. Now remember, in your do step, you start with the general formula, which is in words. So our test statistic is our statistic minus the parameter divided by the standard deviation of the statistic. In this case, we have a formula for our standard deviation, but we don't actually know the population standard deviation, so we replace that with the standard deviation of the statistic. Our mu was our null hypothesis, that was our parameter, and our x bar would be whatever our mean was from our sample. Remember that we're using t's rather than z's, so we have to use n-1 degrees of freedom. So if we go back and look at this in context of that battery problem, we're taking our formula in words, then we're doing the specific formula in symbols, then we're plugging in our numbers, and we're getting the 1.54 for our test statistic. That's our t value. Next up, we're drawing our picture. So we've got our t distribution that looks an awful lot like our normal distribution. It's just got more area in the tails. The center point is the 0, and then we move over to 1.54 or whatever our test statistic was. And then in this case, since our alternative hypothesis is a greater than sign, mu is greater than 30, we're shading above that test statistic. And just like for our z scores earlier in the year where we could use normal CDF, there are some things you could do on your calculator. For now, we'll use the table since that's what we've done so far. So the way we'll use our table is we had a sample size of 15 batteries. Our degrees of freedom is equal to n-1. So we're going to be looking in the row for 15 minus 1, which is 14. We're going to be looking in this row to find the closest thing that we can find to our test statistic, which was the 1.5-ish number. So when we're looking in here, there's nothing that's exactly close to 1.5, but we do have 2 values that would be on either side of that. So using the table, the very best that we can do is to say that our p-value is somewhere between 0.05 and 0.1. Later on, you'll look at the calculator and you'll be able to get a better answer. But for now, that's the best we can do, is that it's somewhere between these two values. So depending on what your alpha level was, so if your alpha level was 0.1, a number that's somewhere between 0.05 and 0.1 would be less than 0.1. And then you would have statistical significance to say that you could reject the null hypothesis. But if your alpha level was 0.05, a number between 0.05 and 0.1 would be bigger than that. So then you would not have statistical evidence and you would fail to reject your null hypothesis. So that's as close as you could get just using the table. We will look at a video then on how to get a more accurate answer using your calculator. It won't be normal CDF, but it will be something similar for our t distribution. Now, just a few notes if you're going to be using table B. Remember that on table B, they had the value from the critical score and up shaded. And if you wanted to do more than that, you would have to use a little bit of thinking, kind of like we did with our table A earlier, where if you wanted the less than, so you wanted a t-score and less than that, one thing you'd have to keep in mind is that just like the normal distribution, the t-distribution is symmetric. So you know that, let's say your t-value, was positive 1.5. And maybe when we went and looked that information up on the table, maybe that worked out to be, 0.3. That was maybe 30% shaded. Because the table is symmetric, even though you can't get a t-value of negative 1.5, so that the other side, even though you can't get that directly from the table, you would still be able to figure out that this would be 30% shaded as well, because it is symmetric. And then same thing, if you know that your t-value is positive 1.5 and also negative 1.5, and you want to find both of these tails total, if this is 30% and this is 30%, then that would be 60% total shaded. So depending on what your alternative hypothesis is, you might have to do a little thinking about how to multiply or find equivalent pieces in table B. Now, when you use your calculator, that's not going to matter. Your calculator will be able to do that for you. Now, just one last reminder. In the previous unit where we did tests and confidence intervals for proportions, we saw how they were connected. And that same connection exists for means as well. So if you do a confidence interval and your null hypothesis value is inside of the interval, then that's evidence to suggest that you would fail to reject your null. And you would expect to get a similar result on your test statistic, where you'd end up with a p-value greater than your alpha level. Same thing, if the null value was outside of the confidence interval, that would be evidence to suggest that it's not a plausible value, and that would result in you rejecting the null hypothesis, and you should get a similar result from the test where your p-value would be smaller than your alpha value. Just a word to remember that. Don't forget that this only works for the two-sided significance tests, so when your alternative hypothesis is not equal to, rather than greater than or less than.